Automatic, Addison.
In this tutorial, we will explore arrays, vectors, and strings using C++. Let's begin by exploring how to manage arrays in C++ for robotics. Arrays are a fundamental data structure that allow you to store and manipulate multiple values of the same type. Let's begin. I may have a terminal window open, and let's move to our folder. Document CPP tutorial. Let's open Visual Studio Code. All right, and let's begin by creating a new file, and we will name it robotarrays.cpp. Robot arrays. Let's get rid of this. And let's begin by typing this into the code editor, #include iostream, using namespace stud, int main, curly braces, const int size equal 5. Let's do int integer array, sensor readings, and the size of the array, we'll put in size here. So I have 5 spots, and we're not running Python, so we need to have the semicolon at the end. And let's say initializing the array. Let's go for int I equals 0, I less than size, I plus plus. Do sensor readings. We'll do I equals I times 10. Okay. And we close this out. And now let's say we are going to access array elements. So accessing array elements. Let's do cout, and we'll do sensor readings, endl, and do for int I equals 0, I less than size, I plus plus. Do cout sensor I plus 1. And we'll do sensor readings. And let's use the I for the index to access the elements, and do endl. All right. Let's do return 0. Okay, how are we looking here? So in this example, we demonstrate how to declare, initialize, and access elements of an array. First, we declare a constant size to represent the size of the array. Then we declare an integer array, sensor readings, with the size of size. Next, we use a for loop to initialize the array elements. In this case, we assign each element a value that is a multiple of 10 based on its index. After initializing the array, we use another for loop to access and print each element of the array. We then use the array indexing syntax, sensor readings I, to access individual elements, where I is the index of the element. Now we run the code by going over here to play. Okay, and we can see in the terminal 0, 10, 20, 30, and 40 for sensors 1, 2, 3, 4, and 5, respectively. So you should see these sensor readings printed in the terminal. Right click, click Run Code. You can see it again without all that gobbledygook when I press play up in here. So this example demonstrates basic management of arrays in C++ for robotics. So arrays they're useful for storing and processing collections of related data, such as sensor readings. You can use robot positions or any other data that needs to be organized and accessed efficiently. When working with arrays, it's important to be mindful of the array size and ensure that you don't access elements outside the valid range to avoid some undefined behavior. Arrays are a powerful tool in robotics programming, allowing you to store and manipulate data efficiently. They're commonly used for tasks such as storing sensor data, tracking robot positions, or representing configuration parameters. Moving on to the next topic, let's explore how to employ vectors in C++ for robotics. Vectors are a dynamic array container provided by the C++ standard library that offer flexibility and convenience when working with resizable arrays. Let's create a new C++ file and name it robotvectors.cpp. Click the files icon on the left, and we'll click New File, and we'll do robot_vectors.cpp. And we need to fix this, my fat finger mistake. There we go. And as we always do, we'll do our pound include IO stream. Let's go to pound include vector using namespace stood int main, do vector int motor speeds, and let's do adding elements to the vector motor speeds dot push back 100. Okay, let's do it again. Motor speeds dot push back 200. Okay, let's do it again. Let's add 150 at the back of the array. Push, vector, which is a resizable array, back 150, 50. Okay, and okay, so we just added elements to the array using the push back operation. So the name of the array and then push back. And now let's access the elements in this, I keep saying array, this vector. So accessing vector elements. And first we're going to do cout motor speeds and L, and we'll do for int I equals 0, I less than motor speeds dot size, and then I plus plus. Let's do cout motor I plus 1. Motor speeds I. We do and L. We do return 0. Okay, so what did we do here? In this example, we demonstrate how to declare, add elements to, and access elements of a vector. First, we include the vector header to use the vector container. Then we declare a vector named motor speeds that will store integer values. To add elements to the vector, we use the pushback member function. In this case, we add 3 motor speed values to the vector. To access the elements of the vector, we use a for loop that iterates from 0 to the size of the vector. We use the size member function to get the number of elements in the vector. Right there. Inside the loop, we access each element using the array indexing syntax motor speeds I, right here, where I is the index of the element. Now right-click, run code. And here we go. You should see the motor speeds printed to the terminal. In robotics projects, you can use vectors to store and process sensor readings, track robot trajectories, manage lists of tasks, or any other scenario where dynamic arrays are needed. Let's close this out. Now let's explore how to manipulate strings in C++ for robotics. Strings are a fundamental data type used to represent and work with text data. Let's create a new file called robotstrings.cpp. Type this into the code editor, include iostring, pound include io. Oh, we need string, handle strings using namespace. Stood. Let's get rid of all that gobbledygook. We need the semicolon. And let's do int main, curly braces as we always do. And we'll do string robot name, and we'll call automatic Addison bot. And let's first start by doing cout robot name, indel, and do cout first character, robot name, and do 0, and indel. Okay. So here we access the string characters, robot name, and the first character using that 0 right there. So now let's modify the string. We'll do robot name 8. 8. Okay, and let's change it to a hyphen. So cout modified robot name. Let's do robot name indel, and do string model equal to x100, and do string full name, and we're going to say robot name plus, and let's add some space, and then plus, and then the model. Okay. This is barking. We need double quotes here. Okay. All right, everything looking good so far. Yep, and now let's put all our output to the terminal window. Using character out, cout, we'll do full name. And let's do full underscore name, indel, inline. And as we always do, we do return 0 and save. So what did we do here? What did we do here? In this example, we demonstrate how to declare, access, modify, and concatenate strings. First, we include the string header to use the string data type. Then we declare a string variable named robot name and assign it a value, automatic Addison bot. To access individual characters of the string, we use the array indexing syntax. We print the first character of the robot name using robot name 0. To modify a character in the string, we use the array indexing syntax and assign a new value to a specific position. In this case, we change the character at this index 8, okay, to a hyphen. To concatenate strings, we use the plus operator. We declare a new string variable, okay, named model, and assign it a value x100. Then we concatenate robot name, a space character, and model to create a new string, full name, which represents the complete name of the robot. Now let's run the code. And there we go. Automatic Addison bot, first character A, automatic E, 0, 1, 2, 3, 4, 5, 6, 7, 8. It's at the 8 spot. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 spot. We did the hyphen replacement. That's what we did up here. So this is the output you should get right here. So this example demonstrates the basic manipulation of strings in C++ for robotics. Strings are essential for working with text data, such as robot names, commands, or messages. Let's explore how to employ character functions in C++ for robotics. Character functions are useful for manipulating and analyzing individual characters in a string. Let's create a new C++ file and name it robotcarefunctions.cpp. Robotcarefunctions.cpp. And let's type the following into the code editor. #include iostream. #include cctype. So using namespace stood. So int main cur command equal f. Checking character properties. If is lower and then command. All right. So if is lower, command, do cout. Command is lowercase. Indel. Now let's do care upper case command equals to upper command. And we'll do cout. We have to close those parentheses out. And let's do cout uppercase command. Uppercase command. Indel. And we'll do checking character equality. Let's check the character equality. So if command equals F, cout, command is F, indel, and we'll do return 0 below. How are we looking? How are we looking? Okay, so in this example, we demonstrate how to use character functions to check character properties, convert character case, and compare characters. You can see that here. So for all this to happen, we have to include this CC type library right there. Then we declare a character variable command and assign it the value F. To check if a character is lowercase, we use the isLower function. It returns a non-zero value if the character is lowercase and 0 otherwise. We use an if statement to check the result and print a message if the command is lowercase. To convert a character to uppercase, we use the toUpper function. It returns the uppercase equivalent of the character. We assign the result to a new character variable, uppercase command, and we print it. To compare characters, we use the equality operator. In this case, we check if the command is equal to the character F. If the condition is true, we print a message indicating that the command is F. Now run the code. We right-click, click Run the Code, and here's the output you should get. Command is lowercase, uppercase command F, and then command is F. You should see these messages indicating that the command is in fact lowercase, the uppercase equivalent of the command. Okay. And the command is F right here printed to the terminal. So in robotics projects, you can use character functions for tasks such as validating user input, processing command strings, or analyzing sensor data that involves individual characters. That's it for this lesson. Keep building.